Hello, good morning students. Today we are going to discuss the bisection method to find the solution of an equation. Numerical, so the topic comes under numerical methods in physics. Now, the theory is if f of x is a continuous function between intervals x is equal to a and x is equal to b, any value of x which satisfies the equation f of x is equal to 0 is a solution of the equation. For example, suppose we have the equation ax squared plus bx plus c equal to 0. So this is your familiar quadratic equation. You know the expression for the solution of this equation. Now, what it means is for a particular value of x, this equation is satisfied. Ax squared plus bx plus c will be equal to 0 for a particular specific value of x. So when you find that value of x, that is called the solution of that particular equation. And if that specific value of x is the solution, so if you give a value, another value of x, this equation will not be satisfied. That means this you may get a value not equal to 0, but you may get a value greater than 0. So when you put say x is equal to x1, you may get a value for this equation not equal to 0 but greater than equal to 0. Sometimes if you put a value x is equal to x2, you may get a value less than 0. So this is, you get a positive value here, and here you get a value negative value here for this equation. Now if it is a continuous function, you will get a value for a particular value of x in between x1 and x2. You will get this equation is exactly equal to 0. Say that value of x is equal to say x3. So when you substitute for x equal to x3, that is ax3 squared plus bx3 plus c. So when you take it, you will be equal, you will get it is equal to 0. And that value of x is called the solution of this particular equation. So when you put x is equal to x1, you get a positive value. When you put x is equal to x2, you got a negative value. And in between x1, x2 and x3, when you put a value of x in between x3 and x2, you got the value. You got a value of this equation. Exactly, this equation is exactly satisfied, and that value of x is called the solution of this equation. Now, suppose we have a continuous function that is plotted in a graph like this. So this is y-axis and this is x-axis. We can write that function as y is equal to say f of x. Okay. So we can change the value of x like this. You can take x is equal to 0. You will get a particular value for y. So you can draw a graph like this. When x is equal to 0, you got a particular value of y. Say the value of y is here. You change the value of x to 1. You got the value of y here. You change the value of x to 2. You got the value of y here. Same way, for different values of x, you got different values of y. So when you plot it in a graph, suppose you got a curve like this. Now you can see that for this particular value of x, say x is equal to a, the function, the value of the function y is equal to is a positive value. For this value of x, say x is equal to b, the value of the function is negative. F of x is positive for this x is equal to a, and f of x is negative for x is equal to b. Now you can be sure that for a particular value of x between a and b, there will be, there the function will be equal to, f of x will be equal to 0. So you have to find this value of x. That is the solution of this particular function. Now in bisection method, let us see in bisection method how we are going to obtain the solution of this such a function. Okay. Now f of x be a continuous function between the intervals x is equal to a and x is equal to b. Any value of x which satisfies the equation f of x is equal to 0 is the solution of this equation. Okay, that I hope this is clear. Let f of a be positive and f of b be negative. So we have put x is equal to a in the function. So that is f of a. We got a value f of a, positive value there. When we substitute x is equal to b, we got a negative value. So then there exists a root of the function, that is value of x for which f of x is equal to 0. That is called the root of the solution between x is equal to a and x is equal to b. Okay. So here is x is equal to a. So we guess we got a value of function, a positive value when we substitute x is equal to a. And when we substitute x is equal to b in this function, we got a negative value. Then we can be sure that there exists a value of at which this function is equal to 0 in between a and b. For this, what we are going to do, that is what we are going to discuss. If for the value of when we substitute x is equal to a, we got a positive value. When we substitute x is equal to b, we got a negative value. Now we are taking a value c equal to a plus b by 2. A plus b by 2. Now put x is equal to c. So when we put x is equal to c, sometimes f of x instead of f of x we put f of c. This may be positive or negative. If it is positive, it will be here. So this value of c, if you may get some positive value for function. Sometimes you may get a negative value for c. So when you substitute c, you may get some negative value for this function. So then c will be here. Now what you got is, if c is positive, f of c is positive, what you can conclude, you can say that the solution is now between c and a, c and b. Solution lies between c and b. If f of c is negative, you can conclude that the solution is now between c and a. So if f of c is positive, you change the value of x from a to c. So you put c is equal to a. Again, so I have written here. Now take c is equal to a plus b by 2. If f of c is equal to 0, then c itself will be a solution, will be the root of the equation. If f of c is less than 0, the root will be between c and a. Will be between c and a. Because we got that already f of a is positive. Now we got f of c is negative. F of c is less than 0 the roots will lie between c and a. Then bisect the interval between c and a. You take c1 is equal to, now you take c1 is equal to a plus c by 2. Then check whether f of c1 is equal to 0 or not. Now on the other hand, if f of c is greater than 0, the root will be between c and b. Then bisect the interval between c and b and check whether it satisfies the equation. If f of c is greater than 0, you have to take c1 is equal to b plus c by 2. b plus c by 2. അപ്പോൾ ഈ സിയുടെ വാല്യൂ എഫ് ഓഫ് സി സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്യുമ്പോൾ എഫ് ഓഫ് സിയുടെ വാല്യൂ പോസിറ്റീവ് ആണെങ്കിൽ ഈ എ മുതൽ ബി വരെയുള്ള ഇൻ്റർവെല്ലായിരിക്കില്ല റൂട്ട്, സി മുതൽ എ ബി വരെയുള്ള ഇൻ്റർവെല്ലായിരിക്കും റൂട്ട്. ഇനി എഫ് ഓഫ് സിയുടെ വാല്യൂ നെഗറ്റീവ് ആണെങ്കിൽ നിങ്ങൾക്ക് കിട്ടുന്നത് സൊല്യൂഷൻ എന്ന് പറയുന്നത് സി മുതൽ എ വരെയുള്ള ഇൻ്റർവെല്ലായിരിക്കും. അപ്പോൾ വീണ്ടും നിങ്ങൾ എന്ത് ചെയ്യുക, അതിനെ ബൈസെക്റ്റ് ചെയ്യുക. സി പ്ലസ് എ ബൈ 2 ഈ കേസിലെടുക്കുക, ആദ്യത്തെ കേസിൽ സി പ്ലസ് ബി ബൈ 2 എടുക്കുക, വീണ്ടും ചെക്ക് ചെയ്യുക. അപ്പോൾ ഈ പ്രോസസ്സ് ഇങ്ങനെ തുടർന്ന് പോകും. സോ കണ്ടിന്യൂ ദിസ് പ്രോസസ് ടിൽ ദ റൂട്ട് ഈസ് ഒബ്റ്റെയിൻഡ് വിത്ത് ദ ഡിസൈർഡ് അക്യുറസി. ഓക്കെ, ഒന്നും കൂടി വിശദമായിട്ട് ഇവിടെ ഒരിക്കൽ കൂടി പറയാം. So we have a continuous function here. So we know for a particular value of this is y is equal to f of x, and this is x along this axis. For a particular value of x, so x is equal to a. Here f of x is positive. This is positive. And a particular value of x, that is say b, x is equal to b, this function is negative. So we can say that the solution lies between a and b. So we don't know the exact value of the solution, so we are taking an approximate solution. Say c is equal to a plus b by 2. Now substitute f of c. Find the value of f of c. If f of c is positive, so we can say that this is c, f of c is positive, so this is f of c. Then you can conclude that the solution is between b and c. Then what do you do? You can find another value of c1. c1 is equal to b plus c by b plus c by 2. You find the value of f of c1. Check whether it is positive or negative. Negative. If f of c1 is negative, this is c1, x is equal to c1, f of c1 is negative. Now you can conclude that the solution is in between c1 and c. Okay. Now you find c plus c1 by 2 again. ഇപ്പോൾ ഇതൊരു പ്രോഗ്രാമിൽ നമ്മൾ ചെയ്യുമ്പോൾ എന്താ ചെയ്യുന്നതെങ്കിൽ ഈ എഫ് ഓഫ് സി ഈസ് പോസിറ്റീവ്, ഈ എയുടെ വാല്യൂ സിയുടെ വാല്യൂ എന്തിലേക്ക് കൊടുക്കും? സി ഈസ് ഈക്വൽ ടു സിയുടെ വാല്യൂ നമ്മൾ എയിലേക്ക് കൊടുക്കും. സി ഈസ് ഈക്വൽ ടു എ. ഓക്കെ, ദെൻ എയിനെ നമുക്ക് ഇങ്ങോട്ട് ഷിഫ്റ്റ് ചെയ്യാം. സിയുടെ പൊസിഷനിലേക്ക് നമുക്ക് എയിനെ ഷിഫ്റ്റ് ചെയ്യാം. അപ്പർ ബൗണ്ടറി. നൗ ബിനെ നമ്മൾ c1 എഫ് ഓഫ് c1 നെഗറ്റീവ് ഇട്ട് കഴിഞ്ഞാൽ c1 ബിനെ നമുക്ക് ഇങ്ങോട്ട് ഷിഫ്റ്റ് ചെയ്യാം. അഗെയിൻ ഈ ചെക്ക് ഇൻ ബിറ്റ്വീൻ ദീസ് വൺ. അഗെയിൻ എ പ്ലസ് ബി ബൈ 2 എടുക്കുക. പോസിറ്റീവ് ആണോ നെഗറ്റീവ് ആണോ കിട്ടുക. ഇങ്ങനെ ചെയ്ത് വരുമ്പോൾ കൂടുതൽ അടുത്തേക്ക് നമുക്ക് വന്നുകൊണ്ടിരിക്കും. സോ ഫൈനലി യു വിൽ റീച്ച് അറ്റ് ദി സൊല്യൂഷൻ. ഓക്കെ, സോ ഇതൊരു പ്രോഗ്രാമിൽ നമുക്ക് ഇതിപ്പം മാനുവലായിട്ട് നമ്മൾ ചെയ്യുമ്പോൾ ഇറ്റ് വിൽ ടേക്ക് ടൈം, ബട്ട് വെൻ യു write a Python program, you can do it very easily. So for this you have to, first of all you have to define the function. So we want to find the solution of this some function. You have to define the function in the program. First, input the upper value of a. So in the function you substitute some value for x, and for that particular value of x, if the function is positive, you can take it as the upper value. Now again you put x, give x another value so that f of x is equal to negative. Then that value is b. So then you can say that the solution lies between a and b. Now if f of a into f of b is greater than 0, find the value of f of a and f of b. Print if both f of a and f of b are positive, or if both f of a and f of b are negative. So we are choosing values of a and b either in this region or in this region. So bisection method will not lead to a solution, because for getting a solution we have to take values of x which lies between on either side of this solution. Okay. First of all, you have to check if f of a into f of b greater than 0, but no road between a and b exit the program. Now, other ways you can compute c is equal to a plus b by 2. If f of c is equal to 0, then c itself will be the solution of this equation. Then you can go to print the value of c. That will be the solution. If f of c is less than 0, replace b with c and go to step 5. Replace b with c. And if f of c is greater than 0, replace a with c and then go to step 5. What we are going to do in step 5? A plus b by 2. Here computing a plus b by 2 again. So continue this process. And finally you will get a particular value of c for which f of c is greater than so equal to 0. Okay. So this is the way we are solving an equation using the bisection method. Thank you.